in this video, we will tackle a common issue when using Django with Azure SQL, handling data integrity problems with CharField and IntegerField. By default, Django with the MS SQL backend doesn't sanitize or truncate strings that exceed the CharField length or handle integers that go beyond their limits. This leads to database errors when saving such values. We will show you how to set up a solution in Django that sanitizes these fields before saving data, ensuring data integrity. By the end, you will have a reusable base model and manager for field sanitization in your Django project. Before we dive into the solution, make sure you have the following prerequisites in place. A Django project, configure it to use Azure SQL as a database backend. This setup ensures we are working in the same environment. Basic familiarity with Django models and model managers. While I will explain everything step by step, having a working knowledge of these concepts will help you to follow along more easily. With these prerequisites ready, let's explore the problem in detail and see how we can fix it. Let's now take a closer look at the problem. By default, Django doesn't perform any validation or sanitization on the size of data being saved to the database for certain fields like CharField and IntegerField. This can lead to runtime errors when the data exceeds the constraints defined in the database schema. To demonstrate this, let's consider the following Django model. The text field is a CharField with a max length of 255 characters, and the number field is an integer field designed to hold integer values. If we try to save an object with a string value that exceeds the max length of the text field, the database will throw an error. For example, this command will result in the following error. This happens because Django doesn't automatically truncate the input to match the max length constraint of the char field. Similarly, if we try to save a value to the number field that exceeds the range of integers supported by SQL Server, we'll encounter another error. For example, this will throw the following error. This happens because the value exceeds the range of an integer in SQL Server, leading to an overflow error. These issues highlight the need for a mechanism to sanitize and validate field values before they are sent to the database. In the next steps, we will implement a solution to handle these scenarios. To resolve the issues with CharField and IntegerField values exceeding their constraints, we will implement a custom solution in a new module, for example, core.models. This module will contain reusable base classes for models and managers, along with utility functions to sanitize field values. Let's start by handling the sanitization of integer field values. SQL Server imposes specific value limits for different integer field types. To address this, we define the acceptable value ranges for each integer field type in a dictionary. The following function, setSanitized integer field, ensures that integer field values fall within the defined database limits. How it works. The function uses getOther to get the current value of the specified field from the object. Attempts to cast the value to an integer. If this fails, it logs a warning and defaults the value to 0. Checks against limits. Retrieves the maximum and minimum allowed values for the field type. If the current value exceeds these limits, it logs another warning and clamps the value to the closest boundary, either the maximum or minimum. If the value is sanitized, the updated value is set back on the object using setOther. This function guarantees that all integer fields values conform to the database constraints before saving, eliminating errors caused by overflows. In the next step, we will implement a similar function for sanitizing CharField values. For CharField, we will implement a function that ensures string values conform to the max length constraint defined in the model. Additionally, handles cases where null equals false but blank equals true, converting none to an empty string. Here is a setSanitized CharField function. How it works. It uses getOther to get the value of the field from the object. If the value is none and the field has null equals false, it replaces the value with an empty string. This ensures that the non-nullable fields have valid data. Checks for length exceeding max length. Converts the value to a string if necessary and checks its length. If the length exceeds max length, it truncates the value to fit and logs a warning. Sets sanitized value back to the object using setUtter. This function confirms that CharField values are valid before being saved to the database, avoiding errors caused by values exceeding the maximum length. Next, we will integrate both the setSanitized_IntegerField and setSanitized_CharField functions into custom model and manager classes. We can consolidate our sanitization functions into a base model and manager. These classes will automatically apply sanitization whenever data is saved or bulk created. The sanitize values function is at the core of the solution. It goes through all the fields in the model and checks if they are CharField or integer field. If the field is a CharField, it applies the logic to truncate the values that are too long. For integer field, it ensures the value stays within valid database limits, except for primary keys. Anything goes wrong during this process, an error is logged. The manager base class handles sanitization during bulk operations, overrides the bulk create method to process each object with sanitized values before saving them. Once sanitization is done, calls the parent bulk create method to save the objects to the database. The model base class takes care of sanitizing individual model instances. It overrides the save method to sanitize the object's fields before saving it to the database. It also uses manager base for its objects manager, so bulk operations are handled automatically. This class is abstract, meaning it does not create its own database table, but serves as a base for other models. This way, sanitization happens every time you save or bulk create objects, helping prevent database errors caused by invalid data. Next, we will extend our test model with those classes. Now, let's see how the sanitization works in practice by testing our test model class. I have updated the test model to use our model base and manager base classes. Here's what the model looks like. Using this model, we will perform two tests, first with the integer field and then with the char field. Let's start with the number field. In the shell, I'll create a new instance with an extremely large value for number. Notice the log output. This indicates that the number exceeded the database limit and our code sanitized it. Now let's check what value was actually saved. As you can see, the value was adjusted to the maximum allowable limit for an integer field in SQL Server. Next, let's test the text field. I will create another instance with an extremely long string. This tells us the text was too long, so it was truncated to fit within the max length constraint of the char field. Let's check the stored value. This confirms that the text was safely truncated to exactly 255 characters, preventing any database errors. With just a few updates to our model structure, we have created a system that handles out-of-range values gracefully and automatically sanitizes them before saving. It's efficient and eliminates the risk of unexpected database errors during runtime. That brings us to the end of this tutorial on sanitizing CharField and IntegerField values in Django. We started by understanding the problem. SQL Server raises errors when CharField values exceed their max length or when IntegerField values are out of range. Then we implemented a robust solution using custom functions, a base manager, and a base model to sanitize and adjust these values before they are saved to the database. By integrating this approach into your Django project, you can handle edge cases more gracefully, avoid runtime database errors, and make your application more resilient. If you found this tutorial helpful, don't forget to like and subscribe for more content like this. And if you are interested in Django project development, check out their website in the description. Thank you for watching and see you in the next one.